Hello, I'm Mr. Bob, and welcome to my Geometry Review video series. This video covers Chapter 9, Section 1, titled The Tangent Ratio. By the end of this video, you will have reviewed recent lessons describing the tangent ratio. Discussions will include using tangents in triangles, writing tangent ratios, using the inverse of a tangent. We'll also look at a real-world problem that requires the use of a tangent ratio for its solution. If you'd like me to cover any of these topics in greater details, please leave your request in the comment section below. Please subscribe to this channel if you find this video to be helpful. Thank you. Okay, before we get going to this review, there's a definition we can look at here, and it's of a tangent. And what is a tangent? So in the right triangle ABC, we see it here to the right, the ratio of the length of the leg opposite angle A to the length of the leg adjacent to angle A is constant. No matter what the lengths are chosen for the sides, no matter how big the triangle is, as long as we have angle A, we know that the side opposite and the side adjacent remain with a constant ratio, the trigonometric ratio. It's called the tangent ratio. And what is the tangent of angle A? The tangent of angle A equals the length of the leg opposite angle A divided by the length of the leg adjacent to angle A. We'll look at it again in the next slide. Okay, objective 1A, using tangents and triangles. So as we just read in the definition, this is where the definition came from. In a right triangle, this one here, ABC, the ratio of the length of the leg opposite angle A to the length of the leg adjacent to angle A, no matter what the lengths are chosen for the sides of the triangles, there's constant. This trigonometric ratio is called the tangent ratio. So as I said before, the tangent of angle A is the length of the opposite leg divided by the length of the adjacent leg. Well, as we see here, this is the opposite leg over here. Opposite leg, here's the angle A. And opposite, so we look at this as opposite. If you're talking about B, this down here would be the opposite, right? This would be the opposite if you're talking about angle B. We're talking about angle A right here. And this is the opposite. And the leg adjacent to angle A is this leg here. It's adjacent means it's like touching it, right? So it's right next to it. Angle A, the leg adjacent, as the opposite means away from it, on the opposite side of the triangle. So that's where we get the ratio. So you divide the opposite leg, the length of the opposite leg, divided by the length of the adjacent leg, and you have the tangent. And that can be used to determine what the angle is, and vice versa. Okay? So, here it says, and you can abbreviate this equation as the tan of A, the tangent of A. The tan of A is equal to the opposite divided by the adjacent. You'll have it shortened in that manner. Okay, example 1, writing tangent ratios. So write the tangent ratios for angle T and angle U. So V in this diagram in the box here is the right angle. These are all right angle triangles, basically, we're going to be talking about here. So that V is the right angle. T and U are not. They're the angles are not right angles. So tangent of T. What is the tangent of T? The tangent of T is the opposite divided by the adjacent. Right, opposite right here. Opposite divided by the adjacent. And it's UV divided by TV. Well, here's TV and here's UV. So we're going to take this length of this leg, which is 3, and we're going to divide it by the length of this leg, which is 4. And what do we get? We get 3/4. That's the tangent ratio. Okay, how about tangent of U? Well, U, oh, by the way, T is down here. So this is T, so this is opposite and adjacent. So now let's look at U. I'm going to change the color. So angle U down here is equal to what? What is the opposite of angle U? The leg opposite is this one here. TV is opposite, right here. TV is opposite. And the adjacent leg is UV. U to V right here. And as you can see, here's the angle, and it's adjacent, so it is touching it, not opposite it, okay? And in that case, we have 4 and 3. So 4, the opposite divided by the adjacent, 3. We have 4/3. Okay, so example 1, under check your understanding, they'd like you to try this on your own. So as always, if you watched my videos, you know, I'll just give you some time to do this by means of you stopping the video and think about this and see if you come up with the answer. And then when you come back, we'll go over it together. Okay, so now that you've had time to go over them and try them out, let's see what we come up with here. So it says, write the tangent ratios for angle K and angle J. Well, what are the tangent? What's the tangent ratio? What is the tan of K? We're going to write down as the tan of K is equal to what? It's the opposite divided by the adjacent, right? Well, here's K, down here's K. Okay, this is angle K right here. And the opposite is JL, which is a 3. And the adjacent is LK or KL, which is a 7. So it's the opposite, 3/7. Okay? Now, what's the next question they're asking here? So in part B, wait, excuse me, we got to do tan, sorry, I'm jumping ahead of myself, tan of J. The tan of J is equal to the opposite of J. Here's J up here in the top. Opposite is the 7. So the opposite is 7/3, the adjacent leg. The adjacent leg touches the angle. The opposite leg does not touch the angle. Okay? Now how is tan of K related to tan of J? Well, as you look at it here, this is 3/7, and the tan of J is 7/3. So those are reciprocals. It's reciprocals, reciprocals. Okay? Good. Okay, objective 1B, it's the second slide for our objective 1, using tangents in triangles. So as stated above on objective 1A, the tangent ratio for an acute angle does not depend on the leg lengths of a right triangle. To see why this is so, consider the congruent angles, angle T and angle T prime, in the two right triangles shown to the right. Okay, you see them, there's TOW, T prime, O prime, W prime. They're similar triangles, not congruent triangles, but they're similar. So how are they similar? Angle TOW is similar to triangle T prime, O prime, W prime by using angle-angle similarity postulate, which says that if you have two angles that are congruent, then the triangles are at least are similar. So what is that? TO divided by, TW, you'll see right here, where'd my pencil go? TW right here divided by T0. So you got excuse me, I'm not reading that correctly. Please forgive me. OW right here divided by T0 is equal to O prime W prime divided by T prime O prime. Okay? And those are corresponding sides of similar triangles are proportional. Okay? So therefore, our triangles are proportional. We've shown that they have proportional sides here because we said that they're equal, that those ratios are equal. So the tan of T is equal to the tan of T prime. So that means that WO divided by TO is the same proportion as W prime O prime divided by T prime O prime. And that's by substitution. We have that. So you can use the tangent ratio to measure distances that would be difficult to measure directly. And we'll see that, I think, in the next slide. Okay, example 2, a real-world connection here. So yeah, as I said, we're going to use that tan ratio right here. It's kind of fun. So it says, your goal in Bryce Canyon National Park is the distant cliff. So you see this guy on skis here, and he needs to get to this distant cliff way over here. And we don't know what that distance is. And of course, it's not. He's not going to fly, so he's going to go down the hill and back up the other side. But let's assuming he could fly through the air directly, and he wants to know the distance from where he is to where that peak is over on Bryce Canyon National Park. How far away is that cliff? So step one, it says, point your compass. So the guy's standing here, and he says, point your compass at the distant feature. So point your compass over here. Okay, we don't care whether it's north, south, east, or west. We just want to point it and get an angle and set this up so we have a zero line. And then it says, and note the reading. I guess you could set it to north or however you want to adjust it, but notice the reading. Then it says turn 90 degrees. So you step and make a turn to face this direction here, 90 degrees, and stride out 50 feet in a straight path. So you're going to travel along 50 feet right over here to this point, point 1. So he measured here over to the cliff, then he turned exactly 90 degrees, stepped off 50 feet. Okay. Then it says turn and point the compass at the same feature again in step 1 and take the reading. Okay, now you get a reading. You're going to go over here and you're going to turn back. It doesn't matter how much you turn at this point. You're going to turn, look toward the peak in this direction and take the reading. So what we're going to do is we're going to get this angle right here that we're going to get, right? This angle here. So it says, now, suppose in step 3 you find that the measure of angle 1, that's the measure of angle 1 right here, is 86 degrees. 86 degrees. Okay, you measured over here, you went 90 degrees, you came over here, and now you're looking back, and it's no longer 90 degrees because you moved this little short distance here, 50 feet, and now you're 86. So when you look at it, 86 degrees, almost 90, but it's not 90. Okay, so to find the distance to the cliff, use the tangent ratio. And what is it? So it says, we know the angle now, 86 degrees. So the tangent of 86 is equal to a ratio, and that ratio is the side opposite. Okay, and what is the side opposite? And the side adjacent, right? So the side opposite is this guy right here. That's the opposite. And the side adjacent is this one down here, 50 feet. Maybe I'll change colors so it'll be more identifiable. So here's the opposite and here's the adjacent. So, and we don't know what this length here going across the valley. We don't know what this length is. That's what we're looking for. So we're going to call that x. So we have x divided by 50. There's our ratio, the tangent ratio. So we're using the tangent ratio. We're going to find it. So x, now we're going to solve for x. So x is equal to 50 times the tan of 86. So you take the 50 here and you move it up here and multiply, right? So x is equal to 50 times the tan of 86. And when you do that, it's approximately equal. Remember that. It's always approximately equal when you're using your calculator. Because unless the number came out exactly 3 or 10 or 120 or 50, then you could say it's actual. But in most cases, it's going to be dot something, something, something out for who knows how far. So it's approximately, in this case, to the nearest foot, it's approximately 715 feet. And we didn't have to do anything other than the 50 feet that we marched off and had a couple compass readings. Okay, example 2, check your understanding. So you know how this works. You go ahead and stop the video and try these on your own, see what you come back with. They're a little tricky, but just take your time and work through them, and when you come back, we'll do them together. Okay. I guess I'm going to assume now that you're pretty much ready to go, so let's get on to the next set of slides here. Okay, so the answers for A, B, and C to the nearest tenth. So what did we do? We wanted this diagram for problem A says we have a 54-degree angle, and we have an adjacent side of 10 and an opposite side of W, and we want to find the value of W to the nearest tenth. So the way we're doing that is we have this, we set up our equation so that we have opposite over adjacent right here, opposite over adjacent, which is W divided by 10 is equal to the tan of 54 degrees. Well, if you solve for W, it ends up being 10 times the tangent of 54 degrees. And 10 times the tangent of 54 degrees ends up being 13.763818. So that's okay. And down to 1/10 is 13.8. And as you notice here, it's approximately, because we use the calculator to solve the tangent of 54 degrees. Now, when we get to problem B, it's a little different in that the W is the adjacent side to the 28-degree angle. So now we have 1 divided by, it's 1.0, divided by W is equal to the tan of 28 degrees. So now we've got to flip it around a little bit, which means we're going to multiply both sides by the tan of 28, and we're going to divide both sides by W. When we do that, we're going to get W equal 1 over 0.531709. Okay? That's how, in order to solve this, we had to do that flip, right? You see that. So we took the W up here, and we brought the tangent to the bottom, and that's, so it's 1 right here, divided by the tan, and is equal to W. So approximately, when we calculate for the tan of 28 degrees, we get 0.531709. And so 1 divided by 0.531709, you get W is equal to 1.88072779. And then that, if you round it to the 10th, okay, that ends up being 1.9 because it's 1.88. The second digit there is an 8. So we round up to 9. Now the next one is not difficult, but you have to figure out which angle you're using, and they want us to solve for W, and we've been using the tangent. They haven't taught us about another possibility, but right now they want you to see if you could figure out which side is opposite and which side is adjacent for the 57 degrees, okay, because we're using the tangent. So W divided by 2, the opposite of 57 degrees, right here. 57, here's the opposite of 57 degrees, W, divided by 2.5. So that's it. W divided by 2.5 is equal to the tangent of 57 degrees. And W, then, is equal to 2.5 times 1.539864. It's approximately equal to the tangent of 57 degrees, is this number here. So that's why it's about, or approximately. And when you multiply these together, you get 3.849,662. If you multiply these two together, and then once you've done that, still W is approximate. Now you're going to round this up to the 10th. And the second digit here is a 4, so we're not rounding it up. Okay, it's still 3.8 is our answer. So you have W is equal to 13.8, W is equal to 1.9, and W is equal to 3.8. As we move on, when we get to problem C, you could have solved this by coming up with the cotangent. Okay, you would have had, it's a different trigonometric function. We haven't talked about that yet. Okay, now on to our third slide for Objective 1, which is Objective 1C, using tangents and triangles. If you know leg lengths for a right triangle, you can find the tangent ratios for each acute angle. Conversely, if you know the tangent ratio for an angle, you can use the inverse tangent, shown here as tan to the -1. We'll call that the inverse tangent, to find the measure of the angle. So let's take a look at that. Okay, example 3, using the inverse of the tangent. The lengths of the sides of triangle BHX are given. You can look at the diagram. HB is 6, BX is 8, and HX is a 10. So those are the side lengths. So it asks, the tangent of x is equal to 6 divided by 8 is equal to 0.75. So we look here, we're looking for angle, the tangent of x. So here's x, right here, tangent of x, and we want the tangent. So it's the opposite divided by the adjacent. And there's our 6 divided by 8, or 0.75, 3/4. So now to solve this and find out what is the angle of x, what's the measure of angle x? So we're going to say the measure, right here, the measure of angle x is equal to the tangent inverse, the tan inverse, or we say the inverse tangent of 0.75. 0.75. 6 divided by 8, you could have that in there too. Use the inverse tangent. And when you do that, the tan inverse, so the inverse tangent of 0.75 is approximately equal to 36.8698 degrees. Okay? And here it is. The measure of angle x is equal to approximately 37 degrees because they wanted the lengths of the sides and find the ratio. And we brought it up to 37. Still approximate, right? Good enough? Okay, so let's move on and try it. Okay, example 3. Check your understanding. So it says, find the measure of angle y to the nearest degree. So they give us a picture here, and we're looking for the tangent, or the inverse tangent here, correct? And what we want to know is why we're saying inverse tangent is we have the numbers, we want to know what the measure is of angle y. What is the, oops, look at this. It's kind of going weird on me. I have to try to undo that. Can I undo that? Nope. Let's see. That happens every once in a while, and I don't know why. I'm trying to figure that out. I haven't figured it out yet. Okay, so now we're going to go back to the colored pencil here. So we know our side, we have y. Angle y is right here. Okay, and we have two sides. The opposite side from y and the adjacent side from y. 100 is opposite and 41 is adjacent. So it says find the measure of angle y to the nearest degree. So go ahead and stop the video, give it a try, and see what you come up with. When you get back, we'll do it together. Okay, now that you've had time to look at it, and we're moving on. So it says find the measure of angle y to the nearest degree. So what do? We say put in your calculator, put in the inverse tangent. When you hit the tangent button, it's usually there's an alternate, you can, a second button or whatever to get the upper value, which you usually on tangent, cotangent, tangent, sine, and cosine, they have the inverse sine, inverse cosine, and inverse tangent. So anyways, you put that in, hit inverse tangent, and then put in 100 divided by 41, because it's opposite, which is 100 right here. Opposite is 100 divided by 41, which is the adjacent. And 100 divided by 41 will give us approximately the measure of angle y. So when we do that and push the button on the calculator, we're going to get 67.706 degrees. And this approximate, this isn't an exact number, it's an approximate. So the approximate answer here is, to the nearest degree, 68 degrees.